All right, we're going to go over the warm-up problems for the multiplication division fractions fluency quiz. So the very first one is 4 2/3 times 1 1/4. So for this, what we're going to want to do is we want to change these to mixed numbers. And I'll show you another version of this in a second, but let's stick with what you learned in elementary school. So sorry, not to turn these into mixed numbers into improper fractions. These are mixed numbers. So to change these to improper fractions, we need to change this 4 into what it represents as a denominator of 3, which means you multiply by 3 and then you add it to 2. So the denominator is still 3. 4 times 3 is 12. Adding to 2 is 14. Same thing with this one. We'll multiply it by the 4, then add it to the 1. So the denominator stays the same, but really what we're doing is this 1 is 4 over 4, so we're adding that in. So now that we have it this way, we can multiply across the top and multiply across the bottom. So I need 14 times 5, let's see, so 4 times 5 is 20, and so that would be 70, and then 3 times 7 is 12. Now that is a answer, but obviously we don't want to leave it like that. So when you're doing the quiz, the answer won't look like this. It'll look reduced, of course. So first thing I notice, these are both even, so they're divisible by 2, so that's 35 and 6, and then I'm trying to think if there's anything else. So I know the factors of 6 are 3 and 2. Let's see, 3 doesn't go into 35, 2 doesn't go into 35. So this is reduced as much as we can, but now we need to turn it into a mixed number. So 6 almost goes perfectly into 35. It was 36, and that'd be perfect. But so we have 5 that we can take out, so that's 30. Left over is 5 over 6. So that's the traditional way that you've learned it. Let me show you another way you can do it. I don't know if this will be faster for you or not, but it's kind of cool because it kind of brings back what we've learned in science with the Punnett squares, if you remember those. So if I think about these numbers that I have up here, like it's set up as if it's 2 numbers multiplied, but it's not. It's actually 4 numbers. There's the 4, the 2/3, the 1, and the 1/4. So if I think of a Punnett square. So there's a 4 and a 2/3 and a 1 and a 1/4. Everything needs to be multiplied by everything. So, and this is one of the reasons why you do want to turn it into mixed numbers, because obviously doing this is going to be a lot, but let's try it out. 1 times 4 is 4. 1 times 2/3 is 2/3. 4 times 1/4 is 4 over 4, which is just 1. And 1/4 times 2/3 is, let's see, 2 over 12, which is the same as 1/6. Okay, so now we need to add all these pieces together. So we have 5, and then 2/3 and 1/6. So we need to change this to 4 over 6 plus 1/6, so we get 5 over 6. So you see we get the same thing. It's just for some of you that might be longer. So that'll work if you have both of them as mixed numbers. So that's number 1. All right, number 2 is 2 3/5 times 3. So we'll want to change this 2 3/5 into an improper fraction. So 5 will be times 2 plus 3, so that's 13, and this is just 3 over 1. 13 times 3, 39 over 5. So what number goes into this perfectly? So like 39 divided by 5, you get 7 out perfectly, which is 35, and then you had 4 left over. Oops, sorry. There you go. Once again, if you really want to do Punnett squares, that would look like this. So there's actually only 2 boxes because you have 2 3/5 and a 3. So that'd be 3 times 2 is 6. 3 times 3/5 is 9 over 5, which is how you get the fact that that's 6 and 1 4/5. So you still get back to the same thing. So sometimes it might be faster and sometimes not so much. All right, the third one is 1/2 times 5/8. This is nice and simple because there's not much we need to do with it. Multiply across the top and across the bottom. 5, and then 2 times 8 is 16, and this can't be reduced, so that's it. So those are the multiplications, so hopefully that was enough for you to kind of remember how to do all that. And you can use a calculator or not use a calculator depending on how much you want to. Now let's move on to division. So the first problem is 2/3 divided by 3/4. Now if you remember elementary school, you learned the flip and multiply method. So basically, because we're wondering how many 3/4 can you get out of 2/3. So 2/3 times 4/3 instead. So multiply across the top and across the bottom, 8 out of 9. So that makes sense because you can't get 3/4 out of 2/3 because 3/4 is more. So you can only get a part of that 3/4 that you want. All right, second one, 10/2 divided by 5/2. These are both improper fractions. If you want to reduce them or do whatever, you can. Let's just go ahead and flip and multiply. Because I wanted you to have, an example where you can reduce first. So we could just multiply everything and then reduce. But the whole cross-canceling thing is basically just reducing right now. So these 2's will cancel each other out because 2/2 is 1. And then 5 and 10 will cancel out, but the 10 is left behind by a 2. So this is 2/1, which is just 2. So basically I can get 2 5/2 out of 10/2, which makes sense. Last one, 1/4 divided by 2 2/5. So I will want to turn this 2 2/5 into a mixed number in order to do this division. So multiply, then add. So the bottom does not change. 2 times 5 is 10, so that'll be 12. So now we'll flip the 12/5 in order to do the multiplication. So 1/4 times 5/12. Multiply across the top and across the bottom. 48. So again, that makes sense that I can't, like, if I have 2 and change, like, it's really hard to get that amount from 1/4. So you can only get part of that 2 that we want. And so that's what that represents.